Finishing up on the last little bit that we did for probability review from your first year. Review from your first year. Tree diagrams and sample spaces are basically picture ways to help you represent information, just like what a Venn diagram is. Okay. This first part up here with the first throw, second throw. This is how you could represent all of your possible options. If you have two die, you have to throw both die. These are basically all the possible answers that you can get. This is an example of a sample space. Sometimes it'll be represented with dots instead of like, the 1, 1, the 1, 2, 2, 2, so on and so forth. Okay, then y'all should use dots to represent the sample space. But basically they just represent the combinations that are possible. Okay? Down here with your tree diagrams, this is again another way to represent pictorially some information that you're given. I guess an example like this could come from, say you have a group of 100 students made up of boys and girls, and you have to make a choice to put them in, a special group. Okay? You have boys, you can either pick a boy or you can either pick a girl for the first person that you choose. After that, say you picked a boy first, then you still got a boy and a girl to choose from, and so on and so forth. Okay? This is an example of a tree diagram that can really expand. Remember, you always put your probabilities on the branches, okay, of the tree diagram. And remember that your branches should total to be 100% or 1, depending on if they give you percentages or decimals. All right? So we're going to look at an example with a tree diagram, and then you guys are going to work on some problems on your own. I'll pop in where I need to. I'll deal with probability. And then Friday we'll start the new stuff. Okay?
So we have a chance over the whole
probability unit. Yeah. And so we'll include this stuff and the new stuff. Alright, ready? So here we go. We got the probability that Andrea passes her French exam is 4/5, and the probability that she passes her mathematics exam is 9/10. Okay?
How do they even get those probabilities?
I guess it must be just based off of her previous performance. Maybe she's taken 5 exams, she's passed 4 of those. She's taken 10 math exams, she passed 9 of those, so they figure that'd be her probability. So what is the probability that she passes both exams? Then we're going to copy and complete the tree diagram showing the probabilities on each branch. If this ever says copy and complete on your IB exam, you make sure that you copy that entire diagram onto your paper or into your answer section and then complete it. Don't just do the part that's missing, no, the whole thing. You understand that? And then C says find the probability that she passes one exam but fails the other. Okay? So, you got Andrea. You got 2 tests that she has to take. Alright? Let's say she takes her French test first. There's 2 outcomes that could happen here. She can either pass her French exam or she can fail her French exam. After she takes French, she has to take math. No matter what happens with that French exam, she's either going to pass her math exam or fail her math exam. Okay? So what is the probability that she passes both exams? How will we figure this out? So, how will we figure this out? The probability that she passes both exams? What am I going to use to figure this out? You multiply them because one outcome does not affect the other. Okay? They're independent events. So no matter what, even if she fails to pass that math exam, she still has the same probability of failing or passing if she fails or passes the French exam, has no effect on whether or not she's going to fail or pass the math exam. Mathematically. Okay? Mathematically. So what is that?
81 over
45.
No. 36. No, it's 60.
Okay, thank you. 36 over 50.
What number is that?
Okay,
I was like, this is some good shit.
So 36 out of 50. And that is, what does that reduce down to be? 18 over 25. I was like 81. So copy and complete the tree diagram. So you've already copied it down, right? Now we gotta complete it. Remember, all your probabilities go on the branches, okay? And each branch should add up to equal 1. In this case, since we're dealing with fractions. So she passes French. They already give us that, it's 4/5. So the likelihood that she'll fail French would be 1/5, because it has to add up to equal a total of 5/5. So if it's 4/5, then it'll be 1/5. Now, if she passes math, what's that probability? 9 out of 10. So your failing would be 1 out of 10. So if she passes French, there's the probability that she might pass math or fail math. But if she fails French, what are the other two outcomes that are missing here in this? That she passes math and she fails math. All right, the same way that they were right. So got an S, right S. So what's the probability that she'll pass math? Still 9/10, and fail math? 1/10. So there you go. Now, since find the probability that she passes one exam but fails the other. This is when you, this is when you go across the branches, okay? So there's different outcomes she can have here. She can pass French and pass math, right? So she passes both. How do you figure out that probability? You multiply them together. So 4/5 times 9/10 is 18/25. Okay, we just figured that out. And again, we get that by multiplying across the branches. But what if she passes French and fails math? That's another option she could have. 4 out of 50, which is 2 out of 25. Now, what if she fails French but passes math? What's that probability? 9/50, because I go continue. Or she could fail both. Poor girl. What's that? 1 out of 50. That's actually, that's pretty low. If she fails both exams, it's 1 out of 50. Okay? Now, I know I didn't ask for all of that, but I just want to review that part about tree diagrams. Okay, you can easily find their probabilities. So now let's find the probability that she passes one exam but fails the other. We're looking at what two probabilities are the ones that are listed in the orange. The pass fail
And the fail pass.
and then the fail pass. Okay? That she passes one but fails the other. So that is 4 over 50 and 9 out of 50. So to find the total would be
13 out of 50.
that she passes one but fails the other. And that would be our answer. Going one step further. What if the question asks you to find the probability that, make sure I word it right.
Given that.
Yeah, exactly. You know what's coming. Okay.
Yeah.
Find the probability that Andrea. I can't word it. I was gonna say passes math.
Given that she's failed.
9/10.
Yeah.
950.
9/10.
As she passes math, given that she fails French. So it'd be
It's given that she fails French, doesn't that mean that it's guaranteed?
How about this? Okay, how about this? Find the probability that she passes at least one exam. Find the probability that she passes at least one exam.
So you have to add all the ones together that aren't the ones where that isn't the one where she fails both.
It would be 49 out of 50. So the probability that she fails at least one.
I'd be done with life after that. Like, it's such good
Oh, I said
probability.
passes. Okay, sorry. That she passes at least one would be 49 out of 50.
That's great.
If she fails, it is.
Okay. And of course you can do conditional probability with this as well. All right. Some of your homework assignments will be like that. Something else that can happen with tree diagrams. Okay. Here's another example. Okay. Say I have a box that has 6 green balls, 4 blue, and 2 yellow. Okay. And I draw 2 marbles. Okay. What did I say? Did I say balls? I'm trying to stay consistent. 2 balls. Okay? I'm going to draw 2 balls. Pick out 2 balls. What's the probability? We're going to do a few. What's the probability that I get a green one? What's the probability that I get at least
One green one?
one blue one? What is the probability that the second one is yellow, given that the first one was blue? Let's see if that works out. Let's just see. Okay? You can draw this one. Okay? So, we're going to do those three. So how many balls do I have in total? I got 12 total. Okay? And when I first reached in to grab a ball, I could get what?
Green, blue, yellow.
A green, a blue, or a yellow. Alright? What are my probabilities that I'll get a green one? 6 out of 12, a blue one, and a yellow one. That was my first pick. But then I reach in again to pick out a different one
A green, a blue, or a yellow.
for each one. A green, a blue, and a yellow.
So, 5 tones? Oh, 5 of them.
Why is it 11?
Because you already picked one.
Because I already picked one the first time. So if I pick a green the first time, what's the probability that I'll get a green? Blue and yellow. Do those still add up to be 11? 11. There you go.
Yeah.
What if I pick blue first? Then it would be what? 6 out of 11, 3 out of 11, 2 out of 11. Last, 6 out of 11, 4 out of 11, 1 out of 11. So that will be your tree diagram to represent that situation when things are not replaced. Okay? So what's the probability of me getting a green ball? It's still, oh, it's 1/2. I got 6 balls total that are green out of 12. So that's 1/2. What's the probability I get at least one blue?
The 2 draws or just one?
At least one blue for my drawings. Those would be what situations? GB.
Blue, blue, blue. all
Blue, blue.
Yellow, blue.
Yellow, blue,
BG.
BG, blue, green, and blue, white. Those would be the 5 probabilities that you have to add to figure out at least one blue. Okay? So I just want, we're not going to fully do all the way out. I just want to make sure you guys know that. So you would add all the ones that are in blue.
So the middle one, would you have to multiply that out?
What do you mean?
Because you get blue first. So would you multiply it by each one and then add blue?
Like,
Wait, I'm confused.
like if it's green and blue, you have to find the
If you get
6,
blue,
12 times 4, 11
Uh-huh.
for that probability.
Yeah.
Then yeah.
And then you add them. And so that's what I'm going to do because of course I picked like really big numbers.
yeah.
So. Lastly, what's the probability that the second one is yellow given the first one is blue?
8, 1, 7,
What's the probability that the second one is yellow given that the first one was blue? What's the probability?
only 8
Oh,
out of 8, 1.
no, that's wrong.
8 out of
8 out of
121?
30.
Try again. 132.
Oh, 132.
And then of course you reduce that. That part, that answer comes from this right here. So you use tree diagrams to find those out as well.
So if each of these two diagrams are good.
If it's a small,
If it allows you to create.
can you do like a 3-step